Hey, what's up, guys? Chris here. I got a new machine in my shop, and if you guys have ever watched any of my other videos where I did machining stuff, my shop has been kind of a mess, but I did clean it up pretty significantly. I'm not quite done because I'm trying to finish on this machine before I wrap everything up, but I organized really everything. I mean, the floors were like covered with stuff from jobs that I was in the middle of, and I really organized everything a lot more than it probably looks like. I don't know, probably not. It's not the focus of the video, obviously, but anyways. So I got the new machine. I didn't do an unboxing video, and I have done it before. I think when I got my air compressor, my Alkin air compressor, but this thing weighs like 600 pounds. So to make a video of like, I got my machine with the booming it down the stairs and the chain block lifting it, hoisting it up. It's not really something to watch. But now that it's set up, and I bought a bench for it, not from Precision Matthews. I bought a bench, a Craftsman from Lowe's, and it was like a 1,400 pound bench that could take 1,400 pounds. But it was so high, this thing was like, the top of it, if the head was all the way up, it would be in between the floor joists. So I just I had a piece of butcher block left from a job, and I put some leveling legs on the front that have the leveling feet, and then 2x8s, and the two 2x8s together. I screwed two 2x8s together on each side and put those in the back, and then I put L brackets into the cinder block, so it's fastened to the wall. I mean, this table is not moving, it's not moving up. I mean, really, it's not moving at all. So it's nice, and I got this bolted to the table through, and it's solid wood butcher block. It's a real butcher block, so it worked out really good. But I'm doing, since I got it, first thing I noticed was, I mean, it's a heavy machine. The Z-axis is not real fun to crank up and down. And especially when it was up that high, you should have seen me. I was like on my knees on the chair up, it's ridiculous. I mean, now I can obviously reach it. It's at a reasonable height, but it's just, I'm definitely going to do the power feed on the, I'm already doing the power feed on the Z, and I'm going to do the X too, just because the table, this is easy, but the table is so long. I mean, it takes a while to crank it from one side to the other. So I had already made, I started to make a video. I had made one clip in the beginning where I was doing the power feed for the Z-axis, and then I ended up changing everything because multiple factors. So also I just fixed up my vise. I actually just got this vise too. This is pretty new. I bought a vise from Harbor Freight, and I redid it, kind of like what I did with my bandsaw. I put a big 2 horsepower motor on it, and anyways, I got a pneumatic jack and put that in, and put a foot pedal, and then I machined this rod because the other one was already starting to bend from doing a couple bearings. So this is going to be, for making keyways is why I brought it up, because I was going to make something to go on the shaft that needed a keyway. And I actually saw a video, the girl Blondie that does Blondie Hacks, the show Blondie Hacks, the channel rather. I get a lot of good information from that channel. She's kind of a badass. She does a lot of machining and stuff like this, like these kind of videos, and a lot of good information. So check that channel out. But when I saw, I was doing the research for the Z power feed, and that was one of the ones that I saw. And I saw at least 3 or 4 that everybody was doing the Priest Tools Z-axis power feed. So I looked it up, and it's like $400, and I already had this power feed motor, this power feed thing that I bought, but it's not the right one for this mill. But I was going to adapt it and make it work. To the point where I already had started. I had already. This was the mounting plate that on like a Bridgeport mill, this would go right onto the knee crank. So that's why it's 450 inch-pounds or 650 inch-pounds, because it's for a much bigger mill. But I mean, this is still a pretty heavy mill, but not compared to those. Anyways, I machined out this hole on the new mill, another hole for the screw, so that these 2 screws, this is already not even fastened. I had taken this handle off, and then this No, I actually left that on. So this was right here, and I have it perfectly centered. If I had that other video still, you'd be able to see it there, but I'll just show you real quick what I was thinking about doing. And then I ended up just saying screw it and ordering it. And I said, you know what, I'll use this motor for the x-axis. And then I get into the x-axis and I start doing some research on that, again, from you guys on YouTube. And I find somebody on YouTube. I gotta look up his name, and I'll mention it in the next clip before this video is over for sure, because this is definitely, you know, and I don't really do that often, but this is worth doing it for sure, because this deserves recognition. The guy made a 3D printed motor mount for the x-axis and a coupling to go right into the bushing that's on there, and has the same design as the hand wheel. And it goes to a keyway for the motor, and then this mounts. I mean, it's an absolute perfect fit. And I printed this seriously heavy. This is with 50% infill. It's ABS with 50% infill, 8 wall layers, 6 top and bottom layers. It took like 8.5 hours to print. So this is extremely tough, extremely strong. More so than I thought. I honestly really favor polycarbonate most of the time, and polycarbonate, carbon fiber, glass fiber, even ABS glass fiber is good. I didn't really favor ABS, but then I built the Voron, and I started making some Voron parts out of ABS glass fiber, and I started realizing that stuff is really strong when you do denser infill, and then so is the regular ABS. Honestly, in some cases, I think regular ABS and regular polycarbonate are stronger than the blends in certain instances, like this one for sure. This is definitely, I don't think this could be any stronger in any other ABS material. I mean, this is incredibly, I mean, you could just smash it. I mean, you hear it fall. It's like a brick. Very surprised at the strength of this thing. So this is going to mount right there, and that's gonna, you know, go. It fits right over that perfectly. The holes line up, everything. He did a really good job designing this. The guy must have had experience with fusion, or I don't know if he had experience with fusion, or if he does this for a living, or if he's just a talented hobbyist. I don't know too much about the guy. It wasn't a very long video, but anyways, he did a great job with this. So, like I said, he deserves the credit for sure. And this was just something he did temporarily because he was going to turn it into a CNC, which honestly, for the price of this, to turn it into a CNC, should have just bought one of these. I don't know that he'll ever. Maybe I'll comment on that video. It's probably too late. He probably already did it, but that machine, you can get that for $5,000. Without the enclosure or the flood cooling system or a lot of the other stuff that I got with it, it's like 10 grand with all that stuff, maybe 9. But for $5,000, you can get a basic model. And then if you want it assembled as well, then you're going to pay even more. I assembled it myself, which is not that. You have to pour the concrete and it has to be all coplanar, and it's very time consuming. But I wanted to do it. So anyways, it's just worth noting that rather than turning a machine like this into a CNC, you can get a CNC for way more reasonable than I ever thought you could. I mean, I never thought I'd get a CNC machine for that price. That's 4 foot by 4 foot inside, enclosed. Even for the price that I paid with all the extra stuff, it's a great price. Anyway, for what it is. So anyways, and I also 3D printed this collet holder over here on the wall, and also this one up here, which that one's really dense ABS glass fiber and is really ridiculously hard as well. And the one on the wall hanging with all the collets in it, that one. And honestly, the 3D printed parts are coming out amazing. Some of these printers that I built are really printing really well. And then obviously the store-bought printers are, you know, the good ones that are notoriously good. The Bamboo, the QIDI has really gotten so much better. They're later printers, newer printers. So anyways, I was going to mount this to that the way that it would have been mounted to the hand wheel on the knee mill, and that was my plan. It was to bolt it to that, and then I had. So this is the, where is it? There's an extension that's for the shaft that for the hand wheel on the mill that it's made for. I'm not sure where I put it. Well, that's not good. It's somewhere here. Anyways, I was going to put that in here, and it was going to just come through there with, and then there's a gear. This gear goes over it. This goes over it, and I took the motor apart, and I left it apart because I figure this is a very common motor for these. I mean, like basically everyone is the same. So I figured maybe some of you guys might have one and want to see it, what it looks like inside. And if you haven't taken it apart, then this is your chance. So I figured I would leave it taken apart so I could show you what it actually has inside and what the gear reduction is. Because it was pretty fascinating, I thought, for somebody like me, and most of the guys that do this kind of stuff are like me, like they took all their toys apart as a kid and all that fun stuff. So, oh, it's in the shaft. The shaft is in the hole. So this gear goes over this, right? And then this is going to be, this comes through here, like that. And then the gear goes, oh no, the other way, I'm sorry. This goes through this way. And then this gear goes on here because there's a key in there. There's a small key that I have installed already. And then it slides on, oh, it's the other way. It slides on the key. And then this is the pinion gear that goes together with this, and that's that, and that's how it feeds. And then there's a castle nut that gets tightened on here, which doesn't fit this, but I could have made it fit that. But now that I saw this guy's project, I don't feel like me making this adapt to the x-axis is going to be better than that. I ordered a speed controller for you know, to do speed and reverse and forward, and you know, left and right, whatever, and a stepper driver and a NEMA 34 100 and something inch-pounds of torque stepper motor. I'm sure it's going to probably, I'm not going to have a screen or any of that stuff. It's going to be a switch and a dial, just like something like this, but it's probably going to do a lot better than this would. And the Z-axis one, I mean, it's $400 instead of making this work, but you know, I'd rather have one that is going to work right. And I could have made it work right, but it was just easier, and I could focus on the x-axis. Honestly, that's what it boils down to. So anyways, this is how these are put together. So there's a spring in there, and that inside the spring there's a coupling that goes onto this, and that's what mates with this and makes the gear turn, right? It's just like a miniature one of these. It's just a very small one of those with the grooves that lock into each other. So that spring tension on the bottom and on the top makes them lock into each other, and then when they lock in, that engages, and then this goes down, the shaft goes down to this big gear on the bottom, which is bolted in here, and then the motor comes down, and it has like a swiveled gear that turns this. So that's a big gear reduction. I mean, the shaft is a 1/4 inch maybe. Hold on. Let's see. The shaft is, it's 375 thousandths, so it's less than 1/2 inch. And this wheel is probably 4 inches. This big gear is probably 4 inches. Let's see. It's yeah, it's 95 millimeters, so it's probably considered a 3.5 or 4 inch gear, probably 4 inch gear. So anyways, it's a big gear reduction, and I guess that's what gives it all that torque. But the gears, you notice, are plastic. That gear is plastic. The gear on here is plastic. The gear in there is not. That gear is metal. This gear is brass. The shaft is metal, and there's a lot of plastic parts, but there's some metal parts. I mean, honestly, I can't say whether it's good or not. Obviously, I haven't done anything useful. I haven't done anything meaningful with it, but I can't say that it's bad either. So, I mean, they've been selling, tons of people have these. They're like all over the place, and they fit like most mills, and honestly, for them to be around this long, they have to be good. So I'm sure it probably does work pretty well. I mean, they're around from all different manufacturers, but they're all over the place. They have been forever. I mean, there's videos out there that are decades old with these. So on older mills, that's really what they fit even better. There's newer ones that actually fit this exact mill, and honestly, the one from Precision Matthews is less expensive. Oh no, I'm sorry, I'm talking about the X-axis is from Precision Matthews. I don't think they have a Z-axis one. They have the X and Y, which there's mounting hardware on theirs, which you can also buy directly from the company. I forget the name of the company right now. It's not a well-known company, but they buy the stuff from this Chinese company, and I'm sure they probably ship it here in bulk because it probably takes a while to get it, and they sell it. You know, you can get it less expensive from the manufacturer, obviously, and they're not that hard to find if you look it up. You know what type it is, and I found it, so I know anybody else can too. And once you look it up and you find it, then you can reach out to the company and you can buy it yourself. But you're gonna wait. And honestly, I didn't want to go that route, or I probably would have just got it from Precision Matthews because I didn't want to wait. Then again, I guess it would depend on the price difference, but I do want to get this thing set up so it can be done and I don't have stuff going on in my shop where I can finish up in here. But this has been really useful because there's certain things that I do, like when I need a small part real quick, and it's not something I want to do in a drill press or with a hand drill, but I also don't want to use the CNC machine. And sometimes I'll say, you know what, screw it, I'll use it. And then the CNC machine it's great as a mill, that like without programming it and just using it with the pendant, but it's very easy to, compared to turning a crank or a handle that you're actually operating the machine, compared to like a button on a little hand pen, this thing, it's like a small keyboard controller. So if I am controlling it like this, you know, these little buttons, it's very easy to make a movement you didn't mean to make, compared to, you know, it's just vastly different. And plus, you lose the feel for it when you're doing something on a whim, and it's not designed and it's not planned. Anyways, that's the part that I was missing and wanted to have a machine that I could do that with. Is that like where I could feel it and I could make something off the top of my head and not have to design it. And then if it works, I'll design it and do it that way. Or if it comes out that good with this, then I won't, or unless I'm going to make more of it. But you know, I'm sure you understand what I mean. But that's why I bought this, and I'm psyched. I've already done a few things with it. I put a bigger lathe chuck on my lathe. I put a 6-inch. I had a 5-inch, and then I also have an 8-inch. But I haven't threaded the plate for it yet. I have to thread the plate because my shaft is an odd size. Typically, most of the lathes this size, this is also like a almost 600-pound lathe, and I've done a lot of modifications to it, so it's probably over 600 pounds now. But typically, they have a 1.5-inch shaft back here that goes to the chuck. This is 1 3/4, and then like the bigger ones have 2-inch or 2.5 or something. I forget what the next one was. I think it's 2-inch. But the most common is 1.5, and mine is 1 3/4. So I have to bore it out. So even with the 8-inch chuck, it's a 1.5-inch hole. So this is, well, let me show you actually. This is my smaller chuck, which actually looks dramatically smaller now next to it. It looks way smaller. But this is the hole that it needs to be, and that's the hole that it is. And it's twice the size almost. So, I mean, it's a pretty good size hole, a pretty good size bore, size shaft for the motor. But this is, I mean, this lathe is not the original M1099 that I bought. This has the variable frequency drive, but it has a 3 horsepower triple phase motor, and probably does 6,000 RPM if I wanted to go that fast, which I don't. But there's reflectors on, there's two, after you thread it in, there's two locking these are M5 bolts that pull down like a fastener that sits behind the head, behind the part that you're threading it onto. So it like locks it in place completely. And I put reflective tape for the tachometer, and I've seen it at 5,500 RPMs, and I haven't turned it up all the way. And that's just with one belt, like the timing belt is still on. So you had different belts you could change before, from the timing belt to one of the other two pulleys, and it would be like low and high speed, or there was actually several speeds you could use, but you had to change the belt every time. So now I don't have to change the belt at all, and I get a ton of torque even at low RPM. And then also I ordered a, I guess I got back into the machining stuff more. I haven't been, well, I have been finishing building and modifying all these 3D printers still, but I've been getting into this, back into this stuff more. I have the, what's it, the electronic lead screw. I saw the guy Cloud42, he's a really smart guy, really intelligent guy that I've honestly learned a lot just watching his channel. He made a really good design for one, and I got the other components, and I'm gonna do that. That's gonna be coming up. I'll probably do some videos on just installing it. I mean, I'm not trying to, you know, do a video like he did competing with I'm not trying to compete with anybody, honestly. I'm not here for that. I'm sure you guys can tell that's not what I'm about. I'm here to, you know, pass along information just like I come and get information from you guys. So when I get all this stuff in, that should be later this week, the end of the week. So later this week or this weekend, I'll probably do another video putting that in. Hopefully it will go pretty quickly. And I'll bring you guys back when I get the Z power feed that's made for this machine, so it should be relatively easy, I'm sure. I mean, in the stuff I've seen so far when I was researching how to do it, which one to get, it seems like a very straightforward process, and it should be easy. So, no, I mean, I've already seen it done, so that's usually all I need, and I can just do it. So we'll see. I'll bring you guys back for that. Oh, and then when I was watching the Blondie Hacks video for the keyways, the broaching, I knew like to make a tool, but the press thing with the broaching, I had never even known about that. Honestly, I learned something really valuable from that channel today. And I ordered a broach kit. I'm gonna make the tool that she made too, but I ordered the broach kit. And the press, she was using like a little 2-ton press, and this is a 20-ton press. And I'm sure it's gonna put it down pretty good. But I'm looking forward to being able to make a perfect keyway with that. But I appreciate that too. She's another very smart, knowledgeable YouTuber that's sharing all their information and knowledge, and is very much appreciated. So anyways, that's it for now. I'm gonna bring you guys back when I have something more for you, but I'm gonna wrap this one up for now. So I think I've pretty much shown you everything that's what I was planning on doing. I mean, I had more elaborate stuff. This shaft has if you guys ever do, if anybody watching this does or is thinking about getting one of these for the Z-axis power feed on a benchtop mill, this thread is way off. It's way off. This is a 5/8 thread, they call it. I had a hydraulic fitting, a JIC 3/8. The JIC 3/8 fit in this perfect. Obviously the flange was useless, but it was tight. They must have literally threaded these with a JIC thread. It's Joint Industrial Commission. They're typical threads on hydraulic fittings. So that's what fits this. I was going to use that and actually drill and tap a set screw to fasten that fitting in here, and then bore out the fitting to be the exact size of this, because it fit absolutely. Those are definitely the threads. They weren't off. It was like threaded perfectly, not loose, not too tight. They're definitely the exact threads. So a 3/8 JIC fitting or JIC thread is going to fit that for sure. That's it. That's what I was planning on, how I was going to adapt the drive system to the hand wheel over here. But also this other one is going to preserve the hand wheel if I ever do want to crank it by hand, which I can't imagine why I would. But if anything ever goes wrong with it, then you can crank it by hand, which is a more practical reason to have it. But yeah, so that's about it. And then, oh, the quill DRO. I do need to get a DRO for it. That's one thing I definitely do need, because that on the CNC machine I'm going to miss really quick by not having an idea where I am and having to watch the hand wheels all the time. And I do it on the lathe, even though I have a digital readout on the lathe. I do sometimes use the hand wheels just because I haven't turned on the DRO, because it's a small job and I'm not going to spend that much time there, so I don't get all into it like that. But when I do, I have everything on, and then I use that. But probably the same thing will happen with this, but I'm going to put a DRO on it anyways, because when I do need it, I do need it. I mean, we all do. It's easy to mess up without having something precisely measuring your movements. So anyways, I'll bring you guys back shortly, and you know, not shortly today, well, shortly, really shortly for you guys. I'm going to call it a day. I had a late night last night working on this stuff, and I'm going to call it a day, and I will bring you guys back when I get the stuff for the mill and for the lathe. The lathe stuff is coming actually on Tuesday. I know the bulk of it's coming. There might be some other miscellaneous parts that aren't there with that'll come after, but the Z-axis for the mill set, I don't even have a shipping information yet. I just ordered it yesterday, and it's Sunday today, so I got an email confirmation that I bought it, but that's about it. So I have no idea when it's coming. But anyways, I will keep you guys posted. It'll be in the same video, so we won't have to be kept posted. So take care, guys. Appreciate you guys as always, and that's it. Signing off. Have a good day, guys. Hey, what's going on, guys? Chris here. So I made a surprising amount of progress for a short period of time since I've been working on these few projects, really. And you guys, if you've seen any of my videos, you probably know that I have several hobbies that I'm kind of all the way into, like the air guns and the 3D printers and the machining and the drones and the ham radio, and the list goes on, but I'll just stop there. But I got recently really back into machining, and I got this manual lathe because if you guys have seen my other videos, a couple people were asking me to do some more videos on the gantry mill, excuse me, which I will do. But this right now, I just got this machine, and I didn't do an unboxing or anything. I'm just showing you guys what I'm doing with it, and I got it because there's some things that I do on the CNC just using the controller to do like a quick. If I get an idea in my head and I want to see it, and I just start making it, and then I put it together, and if it works, I'll design it and make it right, unless it comes out well just out of my head, which sometimes it does. But anyways, it's very easy to hit the wrong button on a controller when you're just hitting a button on a controller. It's like a little keypad, you know, it's a miniature keyboard. So you're hitting the left, right, up, down arrows to move, you know, X and Y, and then the page up and page down to go up and down with Z. And it's very touchy, and it's very easy to make a mistake. So and plus I like a standard traditional mill, but I don't like how heavy the head is, cranking the Z. This is a PM30, it weighs like 600 pounds. So it's a pretty heavy mill. And then I just ran a new air line, so I'd have a blower, an air gun right here with a controllable flow. I've got all my drill bits all over the place because I invested in a couple of really good drill bit sets. I 3D printed the collet holder. I 3D printed the other collet holder that I'm just using for bigger tools, and then the X gantry cranking this thing all the way across. It's a long table, so it's a lot of cranking between that, and it makes you kind of cranky. So between this table going back and forth and the Z going, I'll just show you briefly. This is all being moved around because I'm not done with the Z yet. I actually ordered because I watched, you know, Blondie Hacks, the woman Quinn that does the machining show. She's very knowledgeable, and I actually got a keyway broaching set because of her keyway episode. But she had an episode about her. She has a PM 720 something, and she got the Priest tools. You know, they make a set that lifts it up and down, but I actually ordered it. But so I ordered it a week ago. There's no ship date. It hasn't shipped yet. I emailed them 4 days ago. I still haven't gotten a response. And I've already fully automated my X-axis, and I could have, sorry, air compressor. I could have done the Z by now as well. So I stopped waiting, and I'm gonna do the Z also and just cancel the order, because I'm not gonna wait a month for them to send me, you know, the Z axis when I could do it myself in a day. I'm actually gonna machine the part right after this video to join the, I got another NEMA 34, which this is actually gonna go on the X-axis. I'm gonna switch them, because honestly, I should probably use 2 small ones like this. And then I was gonna use another small one like this. So the lathe, I mentioned in the earlier segment of this video, that I was doing the lead screw, the electronic lead screw, which I've already installed and I'm getting frustrated with. I got a kit that from eBay, but I also ordered the Cloud 42, the guy James from Cloud 42, that he designed. I ordered his electronics, and I'm waiting for the electronics, but I ordered the other kit, not for the electronics. I didn't care about the electronics, for all the other stuff. And none of the other stuff fit, and I had to make it anyway. Like none of it fit. I mean, I got an encoder and a stepper motor and a NEMA 23 that I have to switch. After I go up to a certain speed, it starts like whining, and I've tried every setting, and it's lower at any other setting. This is the best I can get it. So I'm gonna put one of these, and I was gonna put the short one, but I'm actually not one of these exactly. I'm gonna put this size. I'm gonna put a NEMA 34 servo motor this is 4 point something. This is 8 Newton meters. The servo is 12.6. And that's gonna be, you know, that's not going to have any problem keeping up. It's not going to ever lose steps, because it's a whole different thing. So that's appropriate for that. The lathe is not a small lathe. I've got a 3 horsepower, 3-phase motor on it, and with the VFD, and a 6-inch chuck, an 8-inch chuck, you know, a 6-inch 4-jaw chuck. I need something that's going to be able to keep up with it. So I got the right motor. But this motor mount is on the Z. So I'm just going to make, this is going to go right to the Z axis. So this is not something I got anywhere from anybody else. This is the X axis. I'm going to show you in a minute. That's done. It's not fixed where I'm going to keep it. I just have it literally double-sided taped, this controller. And by the way, I have, where are they? The stepper motor drivers for the bigger stepper motors. I have one in there, and then I have 2 or 3 more laying around here somewhere. And you don't need it with that controller that I have there, right here. So these. So I got a bigger one that can control a 34, because I thought I needed it here. So I figured, let me try it on the lathe with one of these, and if it works that well, maybe I won't bother with the servo. But I'm gonna put the servo in. I already ordered it. It's coming tomorrow or Saturday. So I'm gonna put it in. I'm definitely gonna use it, because that's gonna be the most effective way to know that I'm not gonna have it screw up on me at an important moment. And they sent a power supply. Not for this, but for that, and I didn't use it for either one. I had a couple of DIN rail mounted Meanwell 24-volt power supplies, so that's what I mounted here, and I put in the box with my VFD over there. I'll show you that in a minute. Anyways, so I just made this. I'm gonna share a link to the guy's video who designed this for the X-axis. Somebody designed this, and they designed it very well. It fits perfectly. The The dog fits perfectly between the shaft of the motor and and it locks into where your handle went, and it works. It honestly, I printed it much heavier than what his notes recommended. I did 45% infill, 8 wall layers, 8 top and bottom layers of each, and 8 bottom, 8 top, and yeah, and 45% infill with 25% space between the infill, or overlap rather. So it's an incredibly resilient part. It feels like, I don't know, it feels like not typical plastic that you would 3D print for sure. And I printed that on my Voron. My Voron's been printing really well, and so has the QIDI printer I rebuilt. They've been printing incredibly well and incredibly fast. They're like as good as the Bamboo, if not better. And the QIDI Q1 Pro has been surprisingly good. They really made a lot of improvements from the X-Max to that. So maybe I won't have to rebuild that one. It doesn't look like I'm going to. But anyways, I'll show you real quick the X-axis power feed. That's all set. I just have to finalize where I'm wiring it and which motor is going to stay here. But you don't need a motor driver with this. This is it's a stepper motor controller, but it's a ZK-SMC02. It's like 25 bucks on eBay, and on Amazon rather, 25 bucks, and you don't need a stepper driver. The stepper driver costs more than 25 bucks. And this has the screen, the pentanometer, the dual direction, and you can actually solder in a different kind of switch if you want. You're making out really good. And for this application, it's only 4 amp, so it wouldn't be good for, you know, if I wanted to use the full potential of like this bigger motor. That one would probably reach pretty much that full potential. But this one, it's not going to. But I don't need it. That's why I'm probably going to put the smaller motor here. And even on the Z, I don't really need it. It only needs to turn that lead screw up and down. Or bolt, whatever it is. And plus, there's a gas strut in there too. It really doesn't need more than. It probably doesn't even need that. The NEMA 23 probably would have done this. But anyways, this is what I decided to do, and I'm definitely sticking with it. And the servo, I'm going to stick with on that. I ordered another small motor like this in case I wanted to use 2 smaller ones here and use this on something else. And then the servo is going to go over there. But right now I'm just going to test that over there. I'm going to finish it on this, but then I'm going to take one of them over there and just test it on there. Just because I want to, I guess, because I'm going to use the servo anyway. But anyways, here's the power feed. So, and obviously you can turn it faster. Slower. And I've made several, you can see I've made quite a few cuts making parts for these projects. And it blows right through it. It doesn't slow down at all. That's 133 RPM. And that's 230. And then you have your stop button. So you have forward, backward, or clockwise, counterclockwise, run and stop, and then your pentanometer. So and then I just put a little switch right here on the power supply, so that cuts power to everything on the 24 volt. And that's it. So that worked out great. So I'm gonna put the motor up on top and do another one of these, and I'm gonna probably custom design a housing that's going to go right on the side of this to have them right on top of each other, because I did order a DRO as well, and that's going to be on this side, I presume. However, I end up doing it, but I did order a digital readout, an LCD digital readout, a pretty good one, you know, because they have a lot of benefits when you're doing manual milling. And honestly, there's a lot of time when you're doing something that you need a CNC, you need a CNC. When you're doing something that it's in your head and you're getting it out, like into a physical object, sometimes you want to do it hands-on, because you don't even know exactly what you're going to do yet, and as you're doing it, you figure it out. For me, anyway, I know there's other people that are like that. Maybe not everybody who does this is like that, but that's how I am. Sometimes it's in my head and I don't even know exactly how I'm going to do it yet, but when I start doing it, it comes to me. But anyways, so that's why I wanted to get a manual mill, and I'm not doing any more than the 2 power feeds. I'm going to leave this like this because this is a short run, and it's very easy. It's very smooth. So is the X. It's just the X is very long. It's just a very long. It's a long run. So, and it's only moving. They say it's an inch per rotation. I think it's actually less. I want to. You know what? All right. So I'm all the way at the bottom, right? And I'm at about 2.5 inches. So I'm going to do 1 full rotation. Yeah, you're getting a 1/4 inch per turn. A 1/4 inch per turn. So it's quite a few turns to go 37 inches or 35 inches. Anyway, and then back and forth every pass, back and forth, and up and down every tool. Those are the two that are meaningful. So that's why I'm doing them. I'm not going to automate this any more than that because the whole purpose of it was to have a manual machine. But anyways, I'll show you what's going on with the lathe. And I also, so like I said, I invested in some stuff in the shop because I kind of got back into my machining stuff. And I got a Chicago Latrobe like $700 drill bit set and this AccuSize lathe chuck, which I had I forget what the manufacturer was, but this chuck is so damn smooth. It's just so damn smooth. That's the background noise from the VFD, but that thing is just it's so smooth, man. It's just like it's so smooth, and the chuck jaws, they line up so perfectly. This is really quality made. I mean, you can see the difference just in how it closes, just in how seamlessly they meet in the middle, and they don't wiggle. These things like these where you use the chuck key, they on almost every lathe chuck I've seen, they wiggle. You know, these are solid. They barely move. Honestly, you get what you pay for, man. It was like a $300 chuck, but honestly, to me, it was worth every penny because it just smokes every other chuck. My 8-inch jaw, my 8-inch 3 jaw is probably near that quality, and that's made by who makes this? CMEC. This is my 8-inch. It's made by CMEC. You can see this is a monster. But this, honestly, the best part about these bigger, and these both have reversible jaws. You don't have to take them out. Both the 8-inch and the 6-inch. So you don't have to take those jaws out to use them the other way. You know, they unbolt in the front, and then they lock in. After you take the Allen keys out and turn them around, they have a keyway in there that they fit into, so you can't misalign them. It's pretty convenient. But the chuck key is a lot bigger, and I always use my 3/8 right angle impact, and I can't use that now, or I could, but it kind of binds up because this is not quite a 1/2 inch, but I'm using my 8-inch chuck key right now. This is the one that came with it, which the only negative thing about it is that it didn't come with one of these chuck keys that have the Allen key in the back, and that you can slide this to one side for leverage. I don't like that. I like the ones that do that, which I'm kind of surprised, honestly. But anyways, it is what it is. But the chuck I'm incredibly happy with. And it's hard to get a chuck that has a chuck plate for this mill, because for this lathe rather, because this like a standard size lathe chuck, I'm sure you guys probably know, is 1.5 inches, and then it goes up to like 2 inches or 2.5 on bigger lathes, not like a bench lathe. This is 1 3/4 for some reason, and it's 1 3/4 8 TPI, so it's kind of a pain in the neck to find the chuck plate anyway. So, you know, that that the fact that I already had the 6-inch chuck plate and it fit perfectly on this was a huge bonus, and that I got an awesome chuck. And they also have a great locking system. This is a Shop Fox, which is Grizzly is Shop Fox as well now. They have this locking mechanism. I don't know if you can see it. These are like machined metal parts that have an M6, a 5mm Allen, an M6 threaded hole in here, and the countersunk socket head goes down into it, and then it has a beveled part that like pinches it up in there. So I mean, it's not like it's not tight with the threads, but that holding it in there, you never have to worry about it coming loose. It's a nice touch. But anyways, this is the controller for the electronic lead screw that I got with this eBay kit, and you know, I'm not real fond of it. So it does work, but you know, I mean, I've watched a lot of the guy James's videos, and he seems very knowledgeable, and I don't know what his background is, but I mean, he's got to have an engineering background. I mean, he's too knowledgeable not to. Usually, you can only you can only get so far without going to school for it, because you're not being taught. You're teaching yourself, and that's what I do. And I'm not gonna say that I'll ever get to certain places, but I mean, like I've gotten farther than I ever thought I would. I mean, I learned how to write the configuration for the printer configurations on the 3D printers, which that wasn't far-fetched for me. I was always good with computers, but like there's a lot of stuff that I've learned how to do that I didn't think I would be able to. So you surprise yourself when you challenge yourself. But anyways, so here's the encoder. I'll bring you back here real quick. It's kind of tight back here because I got the CNC right up behind me, but I'll bring you over here so you can see how I set this up. So none of this stuff that came with it, this motor mount came with it, that the NEMA 23 is on. This was supposed to be on here, but that doesn't even come close to fitting. So what I did is I machined that aluminum cylinder, and I used that because it's not even the right diameter. I used that to mount it to. I put an M8 bolt in there. I drilled and tapped a M8 hole, M8 1.5, I believe, and I drilled and tapped that, and I put a big long socket head bolt through it with a washer on the end, and some Loctite to lock that in place, and then I crimped this down on here rather than on here, and then I had to get a different belt, and it's honestly been very frustrating because none of the stuff and then you see I had to machine this mount for the encoder. So that's 2 aluminum blocks. Both of those are actually my aluminum chips from the CNC machine that I melted and made ingots out of, and I machined them and welded them together to make a longer piece for the mount for this. So that was fun. You know, that's the whole point of spending $330 on a kit that's ready made, that actually asks you what these diameters are when you order it. Even this pulley, this is supposed to be the exact size from my lathe, right? But if you notice inside here, there's a bushing that I had to make that has a set screw holding it in place. And because that didn't fit either. It was far too big. I mean, it's just, nothing was right. I don't know why they even have different kits and ask you these diameters when they just send you whatever they want to send you. Anyway, it was very frustrating. It is very frustrating, but you know, I don't know. I'll probably send it all back because I'm not going to end up using any of it. It's none of it's any good. It's even the motor mount. I'm using a bigger motor, a different motor. I'm not going to be using the motor mount. I'm going to just order an encoder and I'll send the whole thing back because what did I get for $300? Nothing. The motor I can't use. The motor driver I can't use. The electronics I was never going to use. The pulley I can't use, and I haven't even modified it. I just made a bushing to fit in the middle. And the belts I can't use. I had to buy my own belts for different size. I couldn't use any of it. I couldn't use any of it. So anyways, yeah, I'll probably send that back and just order another encoder. I'll order a higher quality one so it's more reliable. But anyways, that's how far I am now. It does work, but only to a certain speed, and then it stops. So I'll show you. Let's see. So can you see the, let me zoom you in so you can see the lead screw moving. You guys see it moving? So I'm going to speed it up. So it's keeping up till about here. That's at 53 Hertz. And this is with a belt configuration where if this was the straight belt that goes right from the motor to the drive, which is usually how it is, I need to get a new belt, it would be going, it would be, so no, it's stopping already. It's stopping. See? It stopped right there. Look, see, it's struggling? It can't even turn it. And there's not even any weight on it. This is not even engaged. The ball nut's not even engaged. And it can't keep up at, you know, I mean, I have a laser tachometer. I can tell you exactly how fast it's going, but it's not going fast enough for that. I can tell you that for sure. So, you know, that's obvious why I'm not gonna keep that. I'm not gonna keep any of this whole kit because it's useless at this point. And I already ordered my own gears, my own pulleys with the same heavier, not like the GT2, like the 3D printers. It's called I forget what it is. It's like an HT3 or something. So I believe it's something similar along those lines. I can't remember for 100% sure, but anyways, I made a good amount of progress. I mean, I got, if this kit worked, it would be done, but it didn't. So, you know, the servo motor I believe is coming in tomorrow, and that comes with a you know, a servo motor driver. I'll tell you right now, and then I'll bring you guys back and do another video with the ELS from Cloud 42, which I'm excited to see, and with the hopefully with the electronic lead screw done, and with a like a beefy servo motor on it. The servo motor I hope is going to fit in that spot where I don't think it's going to. I'm not going to be able to close that door because there is room from the electronics, but I would have to cut an opening in the cast iron, and I'm not going to do that. I'll cut it in the swinging door and let it stick out the door before I cut it in the cast iron, because the structural integrity of the lathe is way more important than the aesthetics of having a stepper motor or servo motor sticking out the door. So obviously that's going to be the way to go on that. But let's see. So here's the servo motor that I ordered. That's the servo motor I ordered. NEMA 34, 12 nanometer closed loop hybrid servo stepper motor. So it's a hybrid servo stepper motor, I guess. 1700 ounce inch, 156 millimeters, 6 amp, 2-phase servo driver, and 3 meter wire CNC controller kit for CNC router engraving milling machine. So it looks, I mean, that's a NEMA 34 size. So that looks like as long. It looks like it's probably longer than that. It's 150. Oh yeah, no, it's a lot longer than that. That's gonna be big. That's the only downside to it. It's gonna be long and big. It's gonna be wide and long. It's gonna be probably, well, let's see. What's this one? This one's probably 100 millimeter, 4 inches. I would guess. Let's see. Yeah, 4.5. So it's 112 millimeters. So 156 is going to be. It's going to be like 2 more inches. It's going to be like 6.5 inches long. So I'm definitely going to have to make a hole. honestly, I don't even see it where that door closes, because that tool bench is going to be pushed back over there. But anyways, I got some cool tools for the mill. I got some facing tools, a fly cutter. I got the collets with the machine and the stuff to secure stuff down to the bench. I got a 5-inch vise. I got a 3-inch vise, both with the turning tables, and then I got like an actual rotary table. And I'm done. I'm not buying anything else. And then that $400 Z-axis kit, I'm not actually going to use. I'm going to cancel it. I mean, they weren't going to ship it out anytime soon anyways. They haven't even responded to an email in a week, so I'm just going to tell them don't even send it. I'll figure out my own Z-axis. I mean, it'll probably be done in an hour or two. But so I was going to go, I just said screw it, and I was going to just buy it because everything really worked well on everybody else's. I saw a bunch of videos on it, and everybody seemed to go with the same one, and it seemed like the thing to do at the time. But now I did this, and I'm realizing how easy it is for me to actually do it, especially without having to even have a separate stepper driver for each one. You just have a small screen like that to control it, and that does everything. And then I'll probably wire switches off of both of them that have, you know, they go one way or the other, and then I'll have one going up and down, one going left and right, so that I know what the you know, it's a little easier to navigate. And then I'll run the wires for the controls right out to the front, and then they'll be like right at the front of the chip tray. So that's theoretically what I'll do. I'm just throwing ideas out there. I'm not sure 100% yet. This is one of those things, like I am telling you, I just kind of get involved in it, and when I get to the point I need to figure it out, I figure it out. And I don't hesitate to make decisions, so it always works out. So anyways, I'll bring you guys back again soon, and show you the finished product and how it comes out. And then I will definitely be doing some more CNC videos. And the next part that I make, that I actually CNC cut with a design and have it doing the CAD through Fusion, and you know, the post goes into Cut Control, which is the software for the MR-1. So they have a Fusion post setup that you can transfer it pretty easily. So next time I do that, I'll bring you guys in, and I'll have you watch the CNC machine going, because that's honestly a very impressive CNC machine. And honestly, my next planned project on it is going to be two blocks of, I haven't decided if it's going to be steel or cast iron yet, but I'm going to get two 4.5 by 5 by 2 inch high blocks of either steel or cast iron, and I'm going to raise the Z height by 2 inches. So if you see right here, not there, right there, on both sides of this gantry. So let me see what I'm showing you. Yeah, right there. See, right there and right there, right on top of these mounts that are on the linear rails with the lead screws, and underneath the gantry, it's so that it raises it up that full 2 inches. So I'm going to order them 2.5, because they're usually a 1/4 inch smaller, and I'm going to order them, you know, probably 5 by 5, because the 5 inches I'm already accommodating a little bit extra. I do need a full 4.5, so I'm going to get a 5 by 5 by 2.5. Well, two 5 by 5 by 2.5s. And the difference between cast iron and steel is significant in price. I mean, I think the two pieces are like, I looked at some prices, they were like 120, 130 bucks for cast iron, and they were more than that each for steel. And that wasn't like a crazy high carbon steel or something. It was not shit steel. It wasn't like just regular iron, but it was a decent steel, but not a crazy expensive ones like tooling steel would probably be a few $100 per piece. So you know, I'm not looking to spend that much. I mean, if there's a huge benefit to it, I would, but for this application, I don't think there's going to be much benefit between cast iron and steel, to be honest with you, because it's just holding this up. And anything, cast iron is pretty damn sturdy, obviously. The lathe is all made out of it. I mean, this thing is actually all steel and cement, because you know, when you put this together, or if I guess now you don't have to put it together, you can order it put together, but I put mine together, and you know, I had to pour the cement, I had to do the whole 9 yards. So not I had to, I actually wanted to do it. So you know, and masonry, I've been doing home improvements for, you know, 25 years. Jesus, I hate saying that. It makes me feel so old. But yeah, I've been doing home improvements for that long, so masonry has always come with the territory. But anyways, that's it for today, guys. I just wanted to show you how the progress is coming along on these. The x-axis is done. My intent is for the z-axis to be done tonight, and the lead screw project will be done. I mean, I have a thread tapping machine. It's more for outside threads, because I can do outside threads on that too. I have my old. I say my old because I can't use it for that anymore, because I machined I had a thread tapping attachment that went in the tailstock, that it had the MT3 like my tailstock, and it you know, would hold either a thread tap, or it would hold a die, and you know, something the size of that could go into it. You know, not all that far. If you need to do a big bolt, you're in trouble, but it could do a good amount. So I put that on the I machined it to fit one of the collets that has if it's a thread tap. So I machined it like a thread tap, the diameter, the circular diameter, and the 4 flats, and it works great. It locks right in, and you know, that motor that's an AC servo motor, which I do have an AC servo motor, and I considered using, but it's 3 horsepower. It's like stupid powerful. It's too much for the lead screw. Those are really high holding, like that thing can thread. An M20 is the highest I've gone, and a 1 inch I've done in standard, and it threads it through steel like it's not gonna stop. I'm telling you, that thing is crazy powerful. And that was only $800 or $900 I paid for that. So I definitely did good on that. And I've seen them on Amazon now. You can't find them for less than $1,200 or $1,300, and some of them are $2,500. And some of them, they say they do even higher sizes than mine said it did when I bought it, but I don't know how it could be more powerful than that. I'm already threading a 1 inch thread, you know, a 1 inch hole in steel, and it's not stopping. It doesn't even hesitate. It's got a tremendous amount of torque. So those AC servo motors are a sight to hold, a sight to see, something to behold. So anyways, I'm getting tired. So I'm going to let you guys go and get back to finishing this up so I can go home and go to bed. All right. Have a good night, guys. I will bring you back when I have something more to show you. All right. Have a good one.